Hey there, everybody. So today we are going to continue the discussion from the last video of ratios and proportions and extend those to percents. So a percent is a ratio that compares a number to 100. So 79%, if I wanted to write that as a fraction, as a ratio, well, that would be 79 over 100. Now, percentages also can be written as decimals and vice versa. So first thing we're going to do is we are going to convert a decimal to a percent. And the way we do that is to multiply the decimal by 100 and then add a percentage sign. So there's kind of a trick to it. If you'll notice, there's 2 zeros in 100. So all I need to do is move the decimal place 2 places to the right. So if I wanted to express 0.2 as a percentage, then what I would do is move this decimal place 2 places to the right. So there is nothing to the right of that 2, so I need to put a 2 there. I need to put a 0 there. So 0.2 as a percent would be 20%. Now, if I wanted to express 3/8 as a percent, the first thing I would need to do is make 3/8 a fraction. So if I make 3/8 a fraction, I'm going to get 0.375. 0.375. Then if I wanted to write that as a percentage, I need to take that decimal and move it 2 places to the right. So 3/8 as a percent would be 37.5%. Similarly, I can work backwards to convert a percent to a decimal. In order to convert a percent to a decimal, I need to divide by 100. So if I'm dividing by 100, same idea. There's 2 zeros in 100, so I need to work backwards. So I need to move the decimal 2 places to the left. So if I wanted to express 28% as a decimal, I start with that 28. The decimal is right here, even though you can't see it. So if I move that 2 places to the left, 28% would be 0.28. 1.24% as a decimal, I would move that decimal place 2 places to the left, and that's where my new decimal would be. And then, because there's that open space between the decimal, the new decimal, and the 1, I need to fill that with 0. So my decimal would be 0.0124. So that's how we convert, that is how we convert decimals to percentages and vice versa. So the main way we are going to solve percent problems is by using proportions. And the proportions are all going to look like this. We're going to have our percent, and our percent is always going to be out of 100. And then we have our is over of. The is going to be the part, and the of is always going to be the whole. Because a percentage is part of a whole, the whole is just 100. So, just so you have a couple of examples of what these proportions would look like. So if the percent problem is telling you to find a percent, for example, what percent of 252 is 84, then if I look at this proportion over here, how would I set this up? What is my variable? The percent is my variable. So x over 100 equals is the top, so is 84. So 84 is going to be the numerator. And then of 252 is going to be the denominator. There's your proportion that you can set up. Okay? And then you can just cross multiply and solve for x like we did in the previous example, or previous video. The other type of problem could be find part of the base. So if we want to find our is. So what number is, there's our is, so that's my x. Okay, I have a 30%, so percents are always out of 100. And then our of is 90. So I'm going to put the 90 in for the denominator of the second ratio. And then the last type of problem that we could have is find the of. So 16 is, so that's going to go where our is goes. 20%, so 20 is always going to be out of 100 because a percent is always out of 100. So 16 is 20% of what number? I don't know my of, because 16, it's basically saying 16 is part of what number? So that would be your proportion set up there. So let's do a couple problems. 40% of 30 is what number? So just remember, this is the proportion that we are trying to set up. So if I start to fill that proportion out, my percent that's given to me is 40. So 40 out of 100. And then this is saying of 30. So 30 is going to fill out the of category. Is what number? Is my unknown. Okay. I want to make sure up here, because that kind of looks like 15. I want to make sure you know that that is. Okay. And then once we set up our proportion down here, our percent proportion, we can cross multiply. So 30 times 40 is going to give me 1200. 100 times x is going to give me 100x. And so then when I divide both sides by 100, x equals 12. So if I take 12 divided by 30, I would get 40%. Because remember, proportion is saying the left-hand ratio is equaling the right-hand ratio. So let's do the next one. 67.5 is... So 67.5 is 75%. So 75% is going to go there. Percent's always out of 100. And then we were trying to figure out of what number. Well, that's my variable. So now I just need to cross multiply and solve this problem. So if I cross multiply there and there. Okay, so I have 75x equals 675. And then if I divide both sides by 75, I get x equals, 75x equals 6,750. So 6,750 divided by 75, x is going to equal 90. So 67.5 is 75% of 90. Go ahead and try these three on your own. Try to set up the percent proportion and then solve them. So you can double check your work on these three problems. Make sure your percent proportions are right, and then make sure you solved each proportion correctly. Okay? The other thing we can do with percent proportions is set up application problems. So these are actually really helpful in the real world when you have discounts. So 2 different stores are selling a bike you want to buy. At store A, the bike is on sale for 20% off the original price of $240. How much will you save? So store A, the bike is on sale for 20% off. So you want to figure out what is 20% of 240. So if I set up that percent proportion, I get, and if I solve that cross product, so I have 100x equals 4,800. So x equals 48. Now 48 is 20% off. So how much will you save? You will save $48. So I'm going to pause the video here. I want you to do step B. Figure out at store B, the bike is on sale for 25% off the original price of $265. Figure out how much you will save. So I'm going to pause it here and give you time to work that out. Okay, you will see that at store B, you're going to save more money. You're going to save $66.25. But the question is, which bike should you buy? So store A if the original price was $240 and you have a $48 discount because it's 20% off. So if I start at $240 and I subtract the $48, at store A, it's going to cost me $192 to buy the bike. At store B, so now I got to do store B, the bike was originally more expensive. It was $265. I did get a bigger discount, but when I apply that discount onto the original price, you'll see that it is still more money than store A. So you should buy from store A. Oops, wrong form of buy. You should buy from store A because it will be cheaper for you. So even though store B had a bigger discount, a bigger percentage off, it still wasn't the best deal for you. All right, so we will be doing a lot of application problems. I have 2 more for you to try on your own, and then that'll be it for this video. So go ahead and pause the video and try those out. So analyzing these 2 problems will be the last part of this video. So just make sure that you understand, because they're kind of tricky questions a little bit. So you set up your percent proportion correctly, you got an answer, and then you analyze that answer with what the question was actually asking. So if you have any question on that, just let me know. Other than that, have a good rest of your day.